Hi everyone, welcome to this new video from the MZH team. Today we'll go over a practice session on first degree equations with one unknown. First of all, I would like to start with answering a very simple question. What does it mean to solve an equation of first degree with one unknown? To answer this question, we'll work with one example, which is 3x minus 21 equals to 0. When we're asked to solve such an equation, in plain English, it's fair to wonder what does it mean, and the answer is we would want to try to find the value of x such that 3 times that value minus 21 equals 0. All right, we are asked to find the value of x such that 3 times that value minus 21 equals 0. The first thing that can come to mind, and that is fair, is to try to guess the value of x. So let's start with that. Let's go through some values we can try to guess and see if those work. We can start with a value of x equal 0. What we'll do here is that we'll take 0 and we'll replace x by 0. We'll do the math and hopefully we'll find this equation. If we end up finding that 3 times 0 minus 21 is equal to 0, then that will mean that x equals 0 is a good solution for this equation. All right, so here I'm replacing the value of x by 0. This is what I do. This is what I'm doing. So if x equals 0, then hopefully 3 times 0 minus 21 is equal to 0. I develop the left side of the equation. 3 times 0 is equal to 0 minus 21. This gives me minus 21 equal to 0. Then you should ask yourself, is minus 21 equals 0? Well, obviously it is not. This tells us that the value of x equals 0 is unfortunately not correct. So x equals 0 is not a valid solution. Then what we can say, we can persist and say, all right, let's try x equal 1. And similarly, let's replace x by 1. So 3 times 1 equals minus 21. 3 times 1 minus 21 equals 0. If we develop the left side, this means 3 minus 21 equal to 0. If we keep developing the left side, this gives us minus 18 equal to 0. Then again, you ask yourself, is minus 18 equal 0? Then it's not. That means that x equals 1 is not a solution for this equation. We can keep trying. We try x equals to 2, try x up to 3. I've done the math. If x is equal to 2, this gives us minus 15 equal to 0, which is obviously not correct. If x equals 3, this gives us minus 13 equals 0. And again, none of these are legitimate values for legitimate solutions for this equation. You've seen here that trying randomly to find a solution for an equation doesn't scale, because so far we tried 0, 1, 2, and 3. But as you know, solutions to an equation can be negative number. They can be, I've been trying natural numbers, but they can be real numbers. we can have fractions as solutions. It's hard then to guess what are the solutions for an equation, because the things we'll have to try are infinite, and it will take us years to find by guessing, or we'll never be able to find a good solution by just guessing and trying to find it. We've had a theory lesson in our channel about solving first degree equations with one unknown. The good news is there is a deterministic way to solve equations, and you'll be able to solve them easily and come straight to the right results. Here I'm reminding you of the general case for solving a first degree equation with one unknown. If you haven't watched the theory lesson number 1 on solving first degree equations with one unknown, please check it out on our channel. As a small reminder, if we have an equation that can be written such that, it can be written in this form, ax plus b equals to 0, then we know that if a is different than 0, we know that the solution is minus b over a. Once again, if you're not familiar with these results, please check out the theory lesson number 1 on how to solve first degree equations with one unknown. So now, see how it's easy to solve this equation. We're starting with 3x minus 21 equal to 0. We identify that a is 3. We identify that b is minus 21. So the equation can be rewritten as 3x plus minus 21 equal to 0. And we know straight away that the solution is x equals 21 over 3, which is equal to 7. And then we know that the solution is 7. All right. Now I will go over 3 rules that will help you solve solutions of first degree with one unknown. The first important rule is to maintain equality. For this, I would like you to have a mental model of an equation, and this mental model is the one of a balance. When we're asked to solve an equation that is written as 3x plus 2 equals 23, I would like you to keep in mind the model of a balance. In solving an equation, we have on one side of the balance 3x plus 2, and we have on the other side 23. And it's important to maintain this balance, and I'll come to that in a second. But so far, please bear with me, and let's walk through how we can maintain this balance, this equality, and how we can violate that. But the important rule is to be able to always maintain equality when solving an equation. So looking at the right side, let's start by looking at the right side. If I have 3x plus 2 equal 23, then if I subtract minus 7 on both sides, the equality is still true, is still correct. I'm still maintaining the equality in here. The equation still holds. The mental model is you have a balance and then you subtract the same weight on both sides of the balance, then intuitively the balance will remain and the equality is maintained. Similarly, if I add a value on both sides of the equation, the equality is maintained. This is good. The same way, if I divide both sides of the balance by a given number, then the equality is still maintained. And last, if I multiply the same number both sides, then again the equality is maintained. If you keep the balanced mental model, these will make sense. If I have 5 oranges or apples, whatever you like, and I subtract 2 on the other side, the equality will be maintained. Obviously here we suppose that each apple has the same weight, but the idea is if you take or add or divide or multiply by the same factor on both sides, then the equality is maintained. All right. On the left side now, I'm looking at things that violate this equality. One of the cases that we can get that is I can subtract one value on one side but not the other. Again, if you have the mental model of a balance, this is obvious that the equality is not maintained. In similar fashion, if I subtract the other side, the right side, not the left side, and if I subtract different numbers on both sides, or if I subtract on one side and add to the other, or if I divide by different values, or if I multiply by different values, the equality is not maintained. This is a very important rule, and you'll see in a minute why that is. We've seen in the theory lesson number 1 how to solve an equation that can be written under ax plus b equals 0. As we've seen earlier, not all equations are written under the form of ax plus b equals 0. For example, here we're looking at this equation. This equation is 4x plus 2 equals 23 plus x. Well, here we've learned in the theory lesson that we've learned how to solve an equation that is written under ax plus b equals 0. But here we need to transform this equation to the form of ax plus b equals 0. All right? And this is where maintaining equality is important. It's when going through the math to transform it to ax plus b equals 0, we need to do some operations on the equations, and it is very important to maintain equality. Otherwise, we will be solving a different equation, not the one we started with. All right? This will make more sense as I go through this exercise. So here what we want to have equals 0 on the right side. So what we will do is that we'll start by subtracting 23 on both sides. 4x plus 2 minus 23 equals 23 plus x minus 23. So what I've done here, I subtracted minus 23 on both sides. You should ask yourself, are we maintaining equality? Back to what we saw earlier, yes, because we're subtracting the same value on both sides. All right, we keep going. This gives us 4x minus 21. I'm just doing the math. 2 minus 23 minus 21 equals, now I can remove the 23s and I just get x. I remove the 23s because 23 minus 23 equals 0. So all I'm left with is x. All right. Now, similarly here, I'm going for a 0 on the right side. So I will subtract x on both sides. 4x minus 21, 4x minus 21 minus x equals x minus x. Am I maintaining equality? Absolutely, because once again, I am subtracting the same value on both sides. Now I can develop further. 4x minus x equals 3x minus 21 equals to 0. Now this looks pretty close, because we know how to solve ax plus b equals 0. We have 3x minus 21 is equal to 0. Now we have to identify the values of a, the values of b, and using the lesson learned from the theory lesson number 1, we'll be able to get straight to the result. Here I can write this under 3x plus minus 21 equals to 0. This gives me that a is equal to 3 and that b is equal to minus 21, and we know that the solution is minus b over a, which is 21 over 3, which is 7. So my solution is 7. All right. Now this is, if you've noticed, this I call this step by step, because I'm subtracting the right side step by step. I can go much faster, and this will give me, in this case, I will just subtract everything on the right in one shot. This will be 4x plus 2 minus 23 minus x equals 23 plus x minus 23 minus x. I go straight to I can do the development right away. This gives me 3x minus 21 equals 0, right? And I get to the same solution, just less steps. Here what I've done, I've removed everything on the right side in one shot. Of course, I maintain the equality because I removed the same thing on both sides, which means that I'm still solving the right equation, and s equals to 7. As you go through more and more exercises about solving equations, you'll be able to make this transition faster and faster. So here you can visually know that you're taking 4x, you'll be subtracting x, so you can right away write 3x, and you know that you're subtracting minus 23, so you can go straight to it with some experience. But I advise you to start slowly by as we did in a step-by-step mode, by subtracting things on the right side to get to 0, and from there you can apply what you've learned in the theory lesson number 1. After you're done with solving an equation, it is very important to test your result, and this is the third and last rule for solving an equation. Earlier, we've seen that for the equation 4x plus 2 equals 23 plus 7, we found that the solution is 7. The important question to say that how can we be sure that we haven't done any mistake? Because it's very easy to make a mistake while developing an equation. Well, one way to do that is to take the value that we found, in this case 7, and we replace back the value of x, we replace x by 7, all right? So this gives us 4 times 7 plus 2 is supposed to be equal to 23 plus 7. We develop both sides and hopefully we find a real equality. So here 4 times 7 is 28 plus 2, which is 30. And then on the right side, 23 plus 7, 30 equals 30, which means that our math is correct, and we can be confident in saying that the solution to this equation is s equals 7. All right. To show you why it's important to always test your results, we'll go and develop a new, solve this other equation, 5x equals x plus 12. Again, I would like to subtract everything on the right side. I'll start by removing x on both sides. First rule speaks about maintaining equality. I have to make sure that I respect that rule. So I'm subtracting x on both sides. This gives me x plus 12 minus x. All right, just to make it clear, I'm subtracting minus x on both sides. Equality is maintained. I keep developing. 4x equals 12. All right, now I need to remove 12. Obviously, I will subtract 12 on both sides. Pretty easy. All right, so this gives me 4x plus 12 equals 0. A is equal to 4 and B is equal to 12, and this gives me, from the theory lesson number 1, that the solution minus B over A, which is minus 12 over 4, which is minus 3, so the solution is minus 3. I can be confident that my math is correct, that everything is right, and I solve this equation and I can go carry on with my life. However, as I said, the third rule is to always check your results. All right, I'm confident that I haven't done any mistakes in here, but yeah, okay, let's go through this rule and let's check. Right, 5 times minus 3 is equal minus 3 plus 12. All right, I keep developing both sides. Minus 15 is, well, 9. So this gives me minus 15 equals to 9, which is obviously not correct. And now I have a signal that I've made a mistake in developing my equation. I was so confident that I did it right, but when I check, now I found that I've made a mistake. That's why it's very important actually to check your results, because it's so easy to make mistakes. Here I did it on purpose. I made the mistake in here in purpose. If you caught it, great job. If you haven't, we're still learning. We're going through this together. Here I made a mistake in here. If you notice, I violated the equality in here. I was supposed to subtract 12 on both sides. However, I subtracted 12 and I added 12 in here, right? It was a mistake because I was trying to go fast and I made the mistake in here. But checking my results, which is the third rule of solving an equation, allowed me to know that I made a mistake, and now it allows me to correct it. Back to here, we left it at 4x equals 12. Now I will do the right transition. 4x minus 12 is equal to 0. Sorry. So here, a is equal to 4 and b is equal to minus 12. And from the theory lesson, we know that the solution minus b over a is 12 over 4, which is 3. The solution now is supposed to be 3. I can check it. I'll put 3 back into the equation. So 5 multiplied by 3 is supposed to be equal to 3 plus 12. 5 times 3 is 15. And supposed to be equal to 15. Now this equality makes sense. Now I have the confidence that my result is correct. The rules now to solve an equation, to summarize, we've learned in the theory lesson number 1 how to solve equations that can be written as ax plus b equals to 0. Whenever we're given a new equation, we need to transform it into ax plus b equals 0. In doing so, it's important to maintain equality. And after you are done, you should always check your results. Take the solution you found, replace x by that solution, develop the math on both sides, and check if you come to real equality or something that is wrong. Thank you very much for watching this MZH video. If this math episode was helpful to you, please don't forget to like the video, share it with your friends, and subscribe to our channel. The notes are available for download. Just check the description box for the link. We would like to hear from you in the comment section. We will make sure to respond to all comments, and see you in the next video.